Can cardboard and a tiny motor generate electricity? We're going to build it, measure it, and test the science.
First, we make our plan. Good engineering starts with accurate measurements before we cut anything. Our tower is 25 centimeters high. Equal sides and 90-degree corners help keep the structure straight and stable.
We're using 6 blades. A full circle is 360 degrees, so 360 divided by 6 gives 60 degrees between each blade. Now we cut exactly on our lines. Accurate cutting matters because small errors can make the turbine unbalanced.
Before assembly, check that every blade matches. Unequal blades create vibration and waste rotational energy. Triangles are very strong shapes. These supports stop our tower from bending sideways. A straight tower keeps the rotor aligned. If the tower tilts, gravity and vibration can increase friction.
A motor normally turns electrical energy into motion, but rotate its shaft mechanically, and this small permanent magnet motor can work as a generator. Each blade stays 60 degrees from the next. Equal spacing helps distribute mass around the center of rotation. The rotor must be centered on the shaft. Even a small misalignment can cause wobble, vibration, and energy loss. Friction converts some useful mechanical energy into heat. Less rubbing and better alignment means more energy can reach our generator. No real machine is 100% efficient. These 2 terminals are our electrical output. When the shaft rotates, the generator produces a voltage across them. Reverse the direction of rotation, and the output polarity can reverse too. An LED is polarity sensitive, and it needs enough forward voltage before it lights. Now follow the energy. Moving air turns the blades, converts mechanical energy into electrical energy, and the LED converts some of that electrical. Energy changes form. It doesn't appear from nowhere. Watch carefully. As the rotor speeds up, the motor generates more voltage. Once there is enough voltage, our LED begins to light. The moving air is providing the input energy. When this generator spins faster, its generated voltage generally increases. But the result also depends on the motor, blade design, airflow, electrical load, and mechanical losses. We used mathematics to design it, engineering to build it, and physics to turn motion into electricity. Try changing the blade size or angle and see how your results change. That's